In this demo, we're going to take another look at classes. The sample's a little bit similar, or somewhat similar to the last one, except we use inheritance instead of embedded classes. So let's go take a look at our geometry module. So we have our geometry module. The first thing you might notice is that the dimensions are being done differently. So instead of having 4 free-floating constants, we've organized them inside an enumeration. So we have this new data type, is how we can view it, called dimension, that's going to exist in our program. It is a class, and it inherits from enum. So this is what the parentheses are used for on your class header. So we have the keyword class, we have the name of the class, we have the parentheses, and inside the parentheses we say what class we're inheriting from. And I'm inheriting from the class enum in the enum module. Enumerations are used when you have a set of related constants that you want to store, and that's what I had before. But in the previous example, they were kind of floating around loose. Here they're organized within this thing called dimension. It also means that later on, I'll just demo it here, when I go dimension dot, I get the list of values that are in the enum. I don't have to switch screens to remember what I did. I can be working off in a file in another directory. And as long as it knows where dimension is, it can go and hunt those values down, and then I can just pick them off the list. Notice that there's other things in here, MRO, name, and value. Those come from that base enumeration, e.enum. So I get, with inheritance, I get all the functionality of the class I inherit from, or who is my supertype, and then everything I add. And what I added to this one was D1, D2, D3, D4. Here I have a geometry class. This isn't too different than our last example. It's almost identical. It stores the SRID and the dimension. And the dimension will be of type dimension. So I'm expecting someone to send one of these into my class. So if we take a look at my point 2D, this is where we start to see a change compared to the last example. Instead of putting geometry nested inside my class, I decide to extend geometry. So this says class. I want to have a class. Its name is point 2D, but it inherits from geometry. It's going to get whatever geometry has. When someone creates my point, I'm going to get them to send in an X value and a Y value, and optionally an SRID. So what I do here, once my class is initialized, I create a dimension, and I hard code it to 2 because I'm in a 2D point. I use the SRID that the user sends in, right? Or if they don't send one in, I use 3005 as the default. I will then use the X that they send in to add an X attribute onto my class, and I will use the Y value that they send in and add a Y attribute to my class. So once this class initializes, then I will have at least 4 attributes: dim, SRID, X, and Y. I'm just going to put a pass in here, and we'll use this for debugging only. So I have a place to stop actually. So we'll do that. Control KS. So I'm going to put a breakpoint in here, right at this point on line 3, and we'll just got to remember to step into. So I'm going to start a debugging session, start debugging, current Python file. So I'm at this line. I'm about to create a point 2D class, and I'm going to send in a 1 and a 2, 1 being the X, 2 being the Y. So I'll step into. I'm now inside the class, making the class. Now I didn't send an SRID, so the default's going to be set to 3005. The 1 did come across, and so did the 2. Remember that self is an instance of the class, or the object version of the class, and that gets passed in, but it doesn't count as a parameter. Here I'm adding on, so if I take over here in the locals window and I'm dropping the arrow down to expand it, nothing is on this object yet. Once I step over this line, it now has a dimension, and if we take a look at this and expand it, name is D2, value is 2, so that matches name, value. So good so far. SRID coming in set via the default 3005. Now note that self.srid doesn't exist yet, but once I step over, now it does. I'm taking the x value, adding an attribute to my class, and adding another attribute to my class. So now my point is all set up. It's got its x and y value, it's got its SRID, and the fact that it's two-dimensional. I also have a string that were the same function or method as before, where if someone tries to print my object, I return a well-known text version of the point. So I'm just going to, we can try stepping out, but I'll just step over, and we're back here printing, and we can see I've got that method that prints a well-known text version of the point, has executed and sent a string back, and I get my 1, 2, which is the values I put in. That's really important. And now this is a little bit different, because before I had a nested object, an object inside an object. There was sort of 2 levels of dots I had to do to get to the dimension and to get to the SRID. Here, because I descend from that particular object, then I inherited, I guess, the properties and methods at the same level. It's not nested. And so this time I just go point1.dim, where I can hover over it and you can see the value in point1 SRID. Because point 1 is right here, and if I expand it, right, there's my dimension, D2 and a value, SRID, a 1 and a 2. So I'll just step over and let those print, and we can see that it prints out the dimension value and the system reference ID. So this is just trying to show you a different way where we have the exact same information. It prints out roughly the same, right? But we've organized it differently in terms of classes. Instead of nesting one class in the other, we were able to do a similar technique via inheritance. Now, whether you use the nesting or whether you use the inheritance is really going to be up to you as a designer. For the problem that you're trying to solve, or maybe you're trying to write some classes and you're trying to future-proof them for stuff that you may encounter down the road, it's going to be really up to you in your design and what you feel almost at the time would be a good approach to organizing your classes. And because you're the one, because they're your classes and you're the one organizing them, you get to choose how that's done. For now, this concludes this demonstration.